introduce yourself.
Hi, I'm Ruth Geyer, and I'm here today to talk a little bit about the living machine that we've set up here at the Life Center. I live here in the community in Larchmont, and I also teach biology at Sarah Lawrence College. Recently, I worked with teachers here in the Larchmont-Mamaroneck district at a workshop where we built our living machine and learned a little bit about how it functions. And this will be set up here at the Life Center pretty much indefinitely. And we're hoping that visitors will come in and that school children will come in and use it for studies. The living machine has a lot of applications, and hopefully I can share a little bit of that with you right now.
Living machine refers I hear a lot of water bubbling.
There's a lot of water bubbling in the system. We are basically pushing the water through these 4 tanks. It's recirculating. And it starts out here. It's coming in through a simple aquarium pump. You might see the pump down there on the floor. And we're pumping in air and using the air to lift the water through this tube into the next tank. And once water gets pushed into this tank, then by the flow of gravity and the action of the density of the water, it gets pushed into the next tank.
Where did the water come from?
This water we collected from our natural reservoir, the Larchmont Reservoir. The teachers brought lots of buckets in. In fact, I might fill up a little bit today. That's how we did it. And because of evaporation, we might need to add water. I come in once a week to take a look at it and add a little bit each time. But the evaporation doesn't happen too quickly. So there really isn't much maintenance to the living machine. And
did you look for specific specimens in the water, or you just took a bucket of water?
Oh no. This system operates on a principle we call self-organization. The living things will organize themselves and partition themselves according to the habitats of each tank. So we don't make a conscious effort to construct a community of organisms. But what we do is if we find things, anything that we find, we try to find life when we're outside and bring it in and put it in the living machine. And what will happen is the tank here, for example, we call our producer tank, is getting a lot of sunlight. And this tank will also have an artificial light that we're going to add later that will help out in the wintertime especially. And the producer tank, we want to encourage the growth of algae, of green plants, photosynthesizers in the water. And this tank is going to get very, very green when the system is mature, much greener than it is now. But even now you can see the beginnings of algae growing on the side of the tank, and the water's a little green in the interior. And that will just get more and more pronounced as time goes on. So we want to encourage a lot of plant growth in our living machine. That's a good thing, because the plants are going to be making oxygen and using nutrients from the water. The water that gets oxygenated and where the nutrients have basically been sucked up by the plant roots is going to move into our other tanks. It'll move through our marsh system back here into our producer tank, which is going to have fish in it. And we don't want to add fish until the system is a lot more stable than it is now. Basically, we're in a period now of allowing the water chemistry to stabilize, making sure that the water's flowing properly. And since it's getting to be spring outside, things are starting to grow in the reservoir. We're going to start to see emergent plants like cattails and arrowhead and rushes. And we'll start bringing things in and putting it in the living machine. Some of it will do well, some of it won't, but we'll allow the system again to self-organize. Some things will do better in one tank than another, so sometimes we'll add a little bit to each tank to see which environment it likes the best. And some things we already know that, for example, plants will probably like it best in this tank where we're trying to optimize the light. You may wonder what all these rocks are in this tank. And this tank serves a role of being basically a home for microorganisms. And again, what we try to do is optimize the environment or the habitat for microbes. And in this case, we want to have a lot of surface area, and also the rocks serve as a mineral base, a chemical mineral base for the growth of a wide variety of microbes. In particular, we want to have microbes that will basically chew up and eat the nitrogen waste that the fish are going to be producing.
Where did you get the rocks, and are there any special kind of rocks, or they're just...
These are not special rocks.
Mhm.
I bought big bags of rocks from the garden store because we needed so many for this tank. But you can see we also collected rocks from outdoors. It took a long time to collect just a small bucket full of rocks, so it was good that I had brought some supplements.
Do you have to have larger ones at the bottom and smaller ones at the top, or however they fell?
However they fall is fine. I might put some smaller rocks in the system, again, so that we get lots of surface area. What we want to have is a mixture of rocks, preferably from the natural environment, and a lot of the rock, the so-called marble or limestone from the garden store, is from outcroppings in our area or from New York State. So that really does also serve as a natural rock. And it's going to be providing calcium and magnesium and iron and all sorts of mineral compounds to the system. But also that surface area for lots of microbial growth. The microbes like to grow in films on the surfaces of things, and that's when they'll do their job the best. Also with the container filled with rocks, the interior of the container will support the growth of microbes that don't like oxygen. So they'll basically be protected from the oxygenated water that's flowing over them. We could use other things in here, and we might try out some other materials as substrates for surface area. We can put plastic spools in there and various things other than rocks. But you always want to have some rocks in there, again, to provide that mineral base. So the water basically that flows out of this tank, hopefully will have a lot of the nitrogen removed and other nutrients removed. A lot of that nitrogen just gets converted into harmless nitrogen gas, which goes back into the atmosphere, and nitrogen forms a high percentage of the gas in our atmosphere, so that's considered a really nice way to remove nitrogen from your system. Where's all the nitrogen going to come from in this system? Well, it's going to come from the fish. The fish waste is high in ammonia, and if you've ever had an aquarium at home, you know that you can't just put fish in a tank of water and expect them to live. The ammonia and the nitrogen levels will build up and basically poison the fish. So you always have to have some sort of filtering system. People have asked me, where's the filter in the living machine? How do you keep the water clean? But basically, because of the way we've set up our system, allowing it to operate naturally, we don't need an external filter. The system acts as its own filter. The biofilter provides the microorganisms which will help to transform a lot of the compounds into harmless things. The plants will be doing their job to provide oxygen and again to take nutrients up through their roots. Plants will also be putting marsh plants or emergent plants in this system here. I already mentioned things like cattails and arrowhead and rush. The plants that we put in here will also be serving that same purpose of helping to oxygenate the system, and their roots will also provide a lot of surface area for bacteria. And of course, the role that the marsh plays in the natural ecosystem is the same. It's very important, a very important purification stage as water passes through it. Microorganisms and living things do their job of transforming toxic and harmful things into things that are not harmful to the environment and to us.
How long ago did you set this up? How long did it take to get to this point?
We set this up 2 weeks ago, and we made some adjustments and changes in the system. There's a lot of different ways you could set up a living machine, and so we made some choices about how we wanted to set ours up. And it's just been bubbling away for a couple weeks now, and I'm rather pleased with how it's stabilized. There's a few things we might do, like add some more rocks. But basically, I think that we're ready to begin putting more plants in it. And I'm starting to see more plants growing outdoors. So there wasn't so much algal and plant growth in the water. But now that the weather's warming up, I think that we'll be able to do more substantive collecting.
Mm-hmm. Can we stop at this point so I can get a close-up and see what's inside the water?
Moving around.
This is a snail that just...
Yes, this is a pond snail. Snails do really well in the living machine. In fact, they're extremely important members of the community
the
here.
camera to pick up, but can you just tell us what is in here?
Interestingly, I'm already starting to see a lot of life. It's a nice way to bring a pond study indoors because the diversity of life is very, very high in the living machine. We have a recirculating system that in a sense speeds up what's going on in nature, and the high nutrient level also helps to speed that up. So we'll get a large number of different species of organisms. In this tank alone I can see a lot of small invertebrates moving and swimming around in the water, and several kinds of, at least 2 different kinds of snails. Here's some small ones. Moving around on the surface film of the water. Having them so accessible makes it really nice for students, especially younger students, to really interact with the living system, sometimes in a way that's easier and more interesting than going out to a pond and trying to see these things. However, I really strongly like to use the natural environment as a part of using the living machine in education. You have to have both. We have to have that connection with the natural environment, being outdoors, and then coming indoors to do other kinds of studies. Top living machine. And this was very fun to do with the teachers, and with students it's a really fun activity to actually build this little model. It can be done in a short period of time. We made it with recycled soda bottles. The equipment altogether basically requires just buying a pump and a few pieces of tubing and possibly a little connection that can be gotten at any hardware store. And putting this together is a fun activity because it's not always easy to put the tubes together in a way that will make the flow do what you want it to do. So, whoops.
As we can see.
As we can see. So the kids, the teachers, adults, we all have a good time putting them together, experimenting, and getting our little system going. And basically the point being to recirculate the water through 3 cells or compartments, just like in the large living machine. I could also add a 4th compartment. Yeah. Or as many cells or compartments as I want.
Should they have to be the same size? I notice they are. Is that by accident or by design?
They don't have to be the same size. What's important in this small, simple model is that the water level is the same in all of them. But I could have a really big container as long as the water level is the same height as the others. The water will spend more time in the large container than it will in a smaller one. The turnover time will be longer. So the same principle applies in this system of starting out with some fish or some consumers. A bio tank where I'm encouraging the growth of microbes, and another tank where normally where I set this up, I have a light over that tank to encourage the growth of algae and plants. This one I've taken apart and set up many times, so I don't have a strong and mature growth of plants or algae in the system yet. And I'm thinking my 2 fish here are maybe really too much for such a small system. This is really tiny. It's a very miniaturized ecosystem. So the large fish are producing a lot of waste, and I'm not sure I have enough surface area or microbes in this little container to handle that. So I think that I may move my fish into our big tank and see how they do. And probably over the months and years they'll grow bigger and bigger in our living machine. We probably will also add something like a catfish, or we could add crayfish. Crayfish being a pretty voracious predator, so we'll have to see how they would work out with our other kinds of fish. But there are a variety of animals that we could put into our consumer tank.
I remember catfish from when my son had the fish tank in our house, and he was the cleaner-upper at the bottom.
Exactly. That would be the point of getting a catfish in here. Sometimes the goldfish require supplemental feeding. I still have to put goldfish food in there because they're not so good at eating the green algae directly. They like to eat a variety of food, mostly organic matter that's somewhat degraded already. So I do feed the goldfish in this system. There's another type of fish that we may get for our large living machine called a tilapia. And the tilapia is very hardy and will eat anything. And the tilapia don't usually require supplemental feeding unless you want to harvest them for aquaculture. And they taste really good. That's another application. I should mention that the living machines that are designed were designed originally by John Todd, who is a a biologist, a scientist, an environmentalist who's worked for 20 years on this concept of the living machine. And they're actually built and used in waste treatment applications. The water doesn't recycle. The polluted water comes into the system at one end, goes through a series of tanks or compartments, and comes out the other end essentially purified by the action of living things.
Without chemicals. I mean, you're
Without
letting
chemicals
nature
and
do
with a
the-
very efficient use of energy. The living machine uses far less energy than standard wastewater treatment and no chemicals. So it's a really interesting application a lot of people are paying serious attention to. And some large companies that produce a high content of organic matter in their waste stream, like dog food companies, candy or food factories, are actually using living machines to treat their waste effluent. I know that Ben & Jerry's ice cream uses a living machine. The Body Shop has a living machine at one of their factories. There are FLM Chocolate, the chocolate factory, and several dog food factories are using them. So they're not just ideas and they're not just fun to look at and play with in the classroom. They're actually really useful tools that are going to be important as we move into the future of thinking of new ways and better ways to handle all the waste that we produce. And they're also strong educational tools because of how they allow us to think about the natural environment, the importance of living things, and the natural watershed that we actually sit in. And we produce waste and it goes somewhere, and living things have to deal with it. And it would be best to understand them and to think of them as our allies and our friends in the job of treating waste.
Thank you.